Hi, today I'm going to show you how to make the LTC3108 Energy Harvester circuit from Linear Technology. In my last video, where I built a flashlight powered by body heat, I showed you how to make a simple circuit that could step up ultra-low voltages to a level that could light an LED. However, that circuit was not that powerful and efficient. So today, I'm going to show you how to make one that is. This circuit, which is an ultra-low voltage step-up converter, is one of the lowest voltage functioning power management devices on the market. It can work all the way down to an input voltage of around 20 millivolts and be able to output voltages up to 5 volts. It does this by using a resonant step-up oscillator where the voltage is essentially increased by a transformer. The LTC3108 then takes this voltage and outputs a regulated fixed voltage. Okay, now let's take a look at the circuit. Here, we have the basic layout of a functioning LTC3108. This current setup outputs 3.3 volts, which is based upon how the VS1 and VS2 pins are connected. The following diagram describes how these pins need to be connected through the aux and ground pins in order to obtain your output voltage of choice. Also, this current setup requires an input voltage of at least 60 millivolts or so in order to operate, because it is using a 1:20 ratio transformer rather than a 1:100, which would operate down to 20 millivolts. However, a 1:20 ratio transformer is more efficient than a 1:100 ratio at a voltage above 100 millivolts, so we'll be using it instead. Before we continue, I will need to mention that in order to do this project, you should be experienced at soldering, because this will require you to solder surface mount components on a protoboard, as every component is going to be surface mounted. In addition, you will need to be able to make solder traces on the board in order to connect each component together. To start this project, you will need the following components: a protoboard, an LTC3108 chip, a SSOP adapter board, a 1:20 ratio transformer, a 10 microfarad capacitor, a 1 microfarad capacitor, a 10 nanofarad capacitor, and a 330 picofarad capacitor. All links of where to buy these components are in the description below. The first thing we'll need to do is solder the LTC3108 chip to an SSOP adapter board in the specific orientation as shown. In order to do this, I recommend taping the chip to the board like this. And with the soldering iron, press down on each pin individually with the tip by putting a little pressure on it for a few seconds. I would recommend using a sharp soldering tip as each pin is separated by only about 1/10 of a millimeter, and if there's any connection between the pins, the circuit will not work. If you are able to perfectly place the chip onto the adapter board correctly, congratulations, you've completed the hardest part of making the circuit. Now you can start soldering the adapter pins on, but make sure you don't have one for pins 3, 5, 7, and 12 located on the adapter board, as you won't need them. Once the adapter pins are soldered to the board, you can move on to the next step. Next, you will need to pick a spot on your proto board to be used as the input for the LTC3108. You will need to solder a wire through that hole, as shown, and clip the lead of the wire coming out the other side with a pair of wire clippers. This is where the transformer will be. Now it's time to solder the adapter board to the proto board in the same orientation as shown. Once you do that, take your transformer and solder it on with the same technique and orientation like this. Next, you can start soldering on the capacitors in the same positions to each corresponding one as shown. Lastly, solder an output wire and a ground wire in the positions shown and finish up by making the following traces. These traces can be made like this. Once you have finished making the traces, you should be ready to test it. First, let's test it by hooking up a power supply to it and measuring its output voltage with a multimeter, as shown on the right. At the same time, measure its input voltage with another meter on the left, measuring in millivolts. If the output voltage reads at around 3.3 volts, your circuit is working great. Now you can connect an LED to the output and see if it will light up. Also, if you have any thermal electric modules like these lying down in the heatsink, you can try powering the circuit with them and see if it will light the LED. Thank you for watching. Make sure to like, comment, and share this video. If you guys have any questions or concerns, leave it in the comments below and I'll get back to you.